Okay, remember we had the question just now where we took, we had 100, okay, we had x less than or equals to 100, and I wrote it as probability x is the same as this, excuse me, and then we took the midpoint, right? And basically what I did there was I was using what we call the continuity correction. Okay, I was using the continuity correction, or some books call it the half correction. So when you use the normal distribution, to calculate binomial probabilities, you have to use the continuity correction or the half correction. You have to use it. Why? Because the normal distribution is a continuous distribution, whereas the binomial distribution is a discrete distribution. So when we do this approximation, you have to use the half correction or the continuity correction. Okay? And you get a good approximation when your NP and your NQ are both bigger than 5. Okay? That's a thumb of rule, yeah? No, excuse me, a rule of thumb. What am I saying? That's a rule of thumb. Okay? Again, you get a good approximation when NP and NQ are both bigger than 5, yeah? We use it as that's like a rule of thumb you'll find um, in many statistics books, okay? Good. Let's work another example. We have X is binomial. They gave me N is 200 and P is 0.47. Use the normal approximation to find this. So probability X bigger than 100 is the same as probability X. When you say X is bigger than 100, where do you start? 101, correct? So now the midpoint will be 100.5. So once you get this done, stop there and come back to find your mu for Y, which is NP, 200 times 0.7. You'll get a number 94, sigma squared. For Y, also easy, NPQ. Use a calculator and you'll get 49.82. So then we are about to start working with Y, correct? So this is bigger than 100, is the same as bigger than or equals to 101. So therefore, you will find probability of Y bigger than 100.5, the midpoint of this and this, okay? Maybe I shouldn't say that. The midpoint of 100 and 101, 100 plus 101 divided by 2, like I showed you earlier, 100 plus 101 divided by 2, you get 100.5. So now you're ready to start with this. When you start with Y, right, you don't have to worry about bigger than or equals to or less than or equals to. You know why? Because this is a normal random variable. So it's a continuous random variable. It doesn't make any difference if you put it like this or you put it like this. No difference to your answers. Okay. So go there. The rest of it is the same. Change your Y to a Z. So which means you need to take 100.5 and then you need to minus the mean, which is 94. Okay. And then divide by the standard deviation, which is the square root of how much? 49.82. Probability of Z bigger than 0.92. Use your tables. Yeah. Use your tables and work out the answer 0.1788. Okay. Good. Let's move on. We want to talk about sum of independent normal random variables. Okay. So sum of independent normal random variables. So which means if you have Y equals to x1 plus x2 right up to xn, okay, where all the xi's, right, they're normal random variables, right? So the expected value of Y you can easily get will be the expected value of x1 plus the expected value of x2 all the way up to expected value of xn, and the variance of Y, because they're all independent, right? Okay, they're all independent. So the variance of Y will be the variance of x1 plus the variance of x2, yeah, the variance of x2 plus the variance of x3 plus all the way up to variance of xn. Note, Y here will also be a normal random variable. Okay. Okay, next example. Let's look at. So remember, right? Read the question very carefully in any exam that you take. Okay. Here we have got, let me clean this, right? You're told that X is normal with mean 0 and standard deviation, right? This particular book that I am using, they gave me standard deviation instead of variance, okay? So just read the question carefully, right? What is given? So X is normal with mean mu and standard deviation 0.03 L. L is the length of an object. Never mind about that, right? Y is normal with mean 0 and 0.04 L. And Z is normal with mean 0 and 0.05 L. Again, right? Your total X, Y, and Z, they're all normal random variables with means 0 and standard deviation 0.03 L, standard deviation 0.04 L, and standard deviation 0.05 L. These are all standard deviations, right? Careful about that. That's why I wrote sigma, okay? X, Y, and Z are independent. You're asked to find, let me remind you again, right? This is standard deviation, right? This is standard deviation. This is standard deviation. Sometimes when I get caught up in it, I sometimes refer to this as variance, so be careful. This is standard deviation, right? Find the probability that the average of X, Y, and Z. So let's call the average A. The average of X, Y, and Z will be X plus Y plus Z divided by 3. So find the probability that the average of X, Y, and Z is within 0.01 L. Okay. So basically we are looking at, okay, A less than 0.01 L minus 0.01 L. Okay. I could have written, this question could have been better written, but never mind about the question, right? We're just trying to get some practice on normal distribution. So we're trying to find the probability that A is between 0.01 L and negative 0.01 L. Yeah. Find the probability that the average of this is within 0.01 L. Okay. So that's why I wasn't, I mean, we could have written a better question, right? That's why I say if you want to think of it, you can think of this as, when you deal with errors in physics, right? So never mind about that. So now A is an average. So A, X plus Y plus Z over 3. You can find the expected value of A. That's not hard. Expected value of A is just 1/3 of all of these, which is 0. Yeah, can't be easier than that. So let's move the screen up. Okay. So once you have that, okay, that expected value of A is easy. Yeah. So now I need the variance, right? I need the variance. So the variance of A, look, let me write it here, right? A is 1/3, what do you call it? X plus 1/3 Y plus 1/3 Z, if you like. So the variance of A will be 1/9 variance of X plus 1/9 variance of Y plus 1/9 variance of Z. That's what you see here, okay? I just took the 1/9 outside, and variance is, remember, standard deviation squared, right? So I gave you standard deviation in the question. So clean this up a little bit and you'll get, this is the variance of A. So now you know that A is normal with mean what? 0, right? Mean 0. And this is now what? Variance, okay? So this probability is what I'm trying to find. As usual, this random variable, I need to change it to Z. So there you go. So take 0.01 L minus the mean of A, which is 0. Okay, I didn't write it. If you want, you can write it. Okay, divided by the standard deviation of A. Okay, so will be the square root of 0.005 L squared over 9. So do that on the left hand side as well.